we will apply the section formula since ratio is given, and since it is external ratio, we will apply section formula for external division, right? So in this way, we can try. You can try to solve this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution part, right? See, formula and key points we will use in this question is, if a point P divides the line joining A x1 y1 and B x2 y2 in the ratio m is to n externally, then coordinates of point P is mx2 minus nx1 upon m minus n and my2 minus ny1 upon m minus n, right? Equation of tangent to a parabola at point at square and 2at is ty is equal to x plus at square, right? Now standard equation of parabola can be written as y square is equal to 4ax, right? Now let's move to the solution part. We are given y minus 1 whole square is equal to 4 times x minus 1, right? Y minus 1 whole square is equal to 4 times x minus 1. So P has coordinates x equal to 1 plus t square, and P has coordinates x equal to 1 plus t square and y as 1 plus 2t, right? 1 plus 2t. Therefore, the tangent at P can be written as, so the directrix is basically x equal to 0. You can see this. Got it? So coordinates of Q are basically 0 and t plus 1 minus 1 by t, right? You can easily calculate. Okay. Now, if R divides QP externally in the ratio 1 is to 2, therefore x is equal to minus of 1 plus t square and y equal to 1 minus 2 by t, right? R. So t can be written as t equal to 2 upon 1 minus y. Clear? Minus y. Right. Therefore, we can write x plus 1. We can replace t in the equation x is equal to minus of 1 plus t square. Right. So therefore, we will write x plus 1 plus 4 upon 1 minus y whole square to 0. Therefore, we can write x plus 1 into 1 minus y whole square plus 4 equal to 0. Got it? So this is the required answer, right? So let's move to the next question. Question number 8. Question number 8 says the line x minus b plus lambda y equal to 0 cuts the parabola y square is equal to 4ax at P, at1 square 2at1 and Q, at2 square 2at2. If b belongs to 2a to 4a and lambda belongs to r, then t1 t2 belongs to what? So what we can do, since line x minus b plus lambda y equal to 0 cuts the given parabola y square is equal to 4ax at point P and Q. Clear? So first we'll try to make the parabola and the line x minus b plus lambda y equal to 0. And after that, by doing the calculation of slopes, you can easily find the value of t1, t2. So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution part, right? The formula and key points we will use in this question is, slope of a line joining x1 y1 and x2 y2 will be m is equal to y2 minus y1 upon x2 minus x1, right? Clear? Minus b by a. Therefore, the minimum value of t1 t2 is equal to minus 4. Clear? So see, we have a given parabola y square is equal to 4x, and and the 2 points on the parabola are 81 square 281 and 82 square 282, right? And the line x minus b plus lambda y equal to 0 always passes through b0. Slope of PR is equal to slope of QR. Slope of PR should be equal to slope of QR. Therefore, T1 T2 is equal to minus b by a. T1 T2 is equal to question number 9. Question number 9 says the center of the circle passing through the point 0 1 and touching the curve y equal to x square at 2 and 4 is. So we basically have to find the center of circle passing through 0 1. Clear? So the hint of this question is, so first we'll try to find the circle which is passing through 0 1, right? Clear? And we will find the circle and we can calculate the center. And part. So formula and key points we will use in this question is equation of tangent to the curve x square is equal to 4ay at point x1 y1 is, we have to replace x square with x1 and y with y plus y1 by 2. Therefore x1 is equal to 4a into y plus y1 by 2, right? So if we have a circle having equation x square plus y square plus 2gx plus 2fy plus c equal to 0, center of the circle is minus g minus f. Therefore, the equation of a family of circles passing through the intersection of a circle x square plus y square plus 2gx plus 2fy plus c equal to 0 and line lx plus my plus n is equal to 0 is s plus lambda l equal to 0. Clear s plus lambda l equal to 0. Now, the slope of the tangent y is equal to x square at 2 4 is 4 and equation of tangent is 4x minus y minus 4 equal to 0. Got it? Therefore, the equation of circle can be written as x minus 2 whole square plus y minus 4 whole square plus lambda times 4x minus y minus 4 equal to 0, right? It is equation 1. Now, since it passes through 0 1, so let's put the value of 0 1 in the given circle, and after putting the value of 0 1 we can find the value of lambda, which is equal to 13 by 5, right? Now on putting the value of lambda in equation 1 we will get 5 into x minus 2 whole square plus 5 into y minus 4 whole square plus 13 into 4x minus y minus 4 equal to 0, right? So we can solve 5 into x square plus 4 minus 4x plus 5 into y square plus 16 minus 8x plus 52x minus 13y minus 52 equal to 0. Therefore, we can write 5x square plus 5y square plus 32x minus 53y plus 48 equal to 0. Right. So we can write finally the equation of circle as x square plus y square plus 32 by 5x minus 53 by 5y plus 48, right, equal to 0. So the center of the given circle will be minus 16 by 5 and 53 by 5, 53 by 10. Clear? So center will be minus 16 by 5 and 53 by 10. Got it? Okay, let's move to the next question. Question number 10. Question number 10 says equation of common tangents to parabola y equal to x square and y equal to minus x square plus 4x minus 4 is or are. We basically have to find the equation of common tangents to the given parabolas. So see, first we will try, the hint of this question is first we will try to convert the second parabola into the standard form of parabola, right? And we can write the equation of common tangent, and after comparing this we can easily find the if slopes of the tangents, and after that we can easily find the equation of common tangents, right? So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution, right? See, formula and key points we will use in this question is equation of tangent to a parabola x square is equal to 4ay is y is equal to mx minus m square, right? We know this. So the given parabola can be written as y equal to x square, and it can be written as y is equal to 4 into 1 by 4 x square, right? 4 and 4 will cancel out to become x square, right? So it now second parabola is minus of y is equal to minus of x square plus 4x minus 4. So y is when we will take minus common, y is equal to minus of x square minus 4x plus 4, which is equal to 4 times minus 1 by 4 into x minus 2 whole square, right? So tangent to parabola is y is equal to mx minus a square. Therefore, tangents to two parabolas are y is equal to mx minus m square by 4 and y is equal to m of x minus 2 plus m square by 4. Now, these tangents are basically identical. So, m is equal to 0 and or 4. M is equal to 0 or 4. Got it? So, common tangents can be written as y. First, we will put m is equal to 0, and after that, we will put m equal to 4. Therefore, common tangents are y equal to 0 and y is equal to 4x minus 4. Clear? Therefore, option A is the right answer. Option A, y is equal to 4 into x minus 4 and y is equal to 0 is the right answer. Got it? Okay, let's move to the next question. Question number 11. Question number 11 says the angle between tangents drawn from point 1,4 to the parabola y square is equal to 4x is. Clear? So we basically have to find the angle of tangents drawn from point 1 and 4, right, to the given parabola. Okay, so the hint of this question is we can draw that we can write the equation of tangent from 1,4 to the parabola y square is equal to 4x by using the given form, by using the required formula, right? And after that we can easily find the two tangents can be found, and after that we can easily find the angle between two tangents, right? So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds we will discuss the solution part, right? Solution part. Formula and key points we will use in this question is equation of tangent to parabola y square is equal to 4ax is y is equal to mx plus a by m, right? So y is equal to mx plus 1 by m passes through 1 and 4, right? Y is equal to mx plus 1 by m passes through 1 and 4. So by putting the value of 1 and 4 in the given equation, y is equal to mx plus 1 by m square minus 4m plus 1 is equal to 0. Clear? So now we know that tan theta is equal to m1 minus m2 upon 1 plus m1 and 2, right? So m1 and minus m2 can be written as root over m1 plus m2 whole square minus 4m1 m2 upon 1 plus m1 m2, right? Why we have done this? Because we are given a quadratic equation in terms of m, so we can find the value of suppose m1 and m1 m2 are roots of that quadratic equation, so we can easily find the sum of roots, that is m1 plus m2, and product of root, that is m1 m2, right? So we have to basically convert the terms m1 m2 in terms of m1 plus m2 or m1 plus m2 and m1 m2, right? Therefore we have written m1 minus m2 in terms of m1 plus m2 and m1 m2, right? So m1 plus m2 will be 4 and m1 m2 will be 1. right? So let's put the value of m1 plus m2 as 4 and m1 m2 as 1. We will get root over 16 minus 4 upon 1 plus 1 is equal to 2 root 3 upon 2, which is equal to root 3. Clear? Therefore theta is equal to 60 degree, which is equal to pi by 3. Clear? So theta will be equal to pi by 3. Option C is the right answer. Got it? Option C should be the right answer. Clear? Okay, let's move to the next question. Question number 12. Question number 12 says if the lines y minus b is equal to m1 x minus a plus y minus b into m2 x plus a are the tangents to the parabola y square is equal to 4ax, then which option will be correct? M1 plus m2 equal to 0, m1 m2 is equal to 1, m1 m2 is equal m1 m2 is equal to 1, m1 m2 is equal to minus 1, and m1 plus m2 is equal to 1. Clear? So the hint of this question is we know that uh, any tangent drawn from the directrix of a parabola is perpendicular, right? So first we will check that if these lines are these lines are on the directrix of equation or not. If it is on directrix, then m1 m2 will be minus 1, since these are the tangents from directrix are perpendicular, right? So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds we will discuss the solution part, right? Solution part. The formula and key points we will use in this question is the tangents drawn from directrix to a parabola are perpendicular, right? So let's move to the solution. Both the given lines are basically passing through minus ab, right, which is a point on directrix, and directrix is basically x equal to minus a, right? So both these points are on the directrix. Clear? Therefore the tangents drawn from minus ab are basically perpendicular, because tangents drawn from the directrix to a parabola are perpendicular. Therefore m1 m2 will be equal to minus 1. Clear? M1 m2 will be equal to minus 1. So option C is the right answer. Option C, m1 m2 is equal to minus 1, is the right answer. In this way we have discussed a lot of different types of questions on parabola. Hope you understood the concepts, right, and how to apply the concepts in the question, and hope. Thank you so much. Hello everyone, welcome to today's lecture. So in today's lecture we'll practice some more questions based on parabola. In today's lecture we will start from question number 13 and we will discuss till question number 18. So let's start with question number 13. Question number 13 says set of values of h for which the number of distinct common normals of x minus 2 whole square equal to 4 times y minus 3 and x square plus y square minus 2x minus hy minus c equal to 0, where c greater than 0 is 3. Clear? So we basically have to find the set of values of h, right? So what we have to do, we are given two parabolas, right? Clear? First we will try to convert the second parabola x square plus y square minus 2x, second circle, sorry, second curve, which is circle, and we will try to convert it into standard form, which is circle is x square plus y square minus 2x minus hy minus c equal to 0, and we will write the equation of common normal. Clear? Equation of normal to both the circles, and after comparing the normal, we can easily find the values of set of values of h, right? So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds we will discuss the solution part, right? Part formula and key points we will use in this question is the equation of normal to the parabola y square is equal to 4ax is y is equal to mx minus 2am minus am cube, right? Now normal to a circle passes through the center of the circle, we all know. Clear? Right? Okay, so the equation of normal of x minus 2 whole square is equal to 4 into y minus x is x minus 2 is equal to m of y minus 3 minus 2m minus m cube. Now since if it passes through 1 and h by 2, then 1 minus 2 into m into h by 2 minus 3 minus 2m minus m cube. Therefore 2m cube plus m of h 10 minus h minus 2 is equal to 0. Suppose say it as fm. This equation will give three distinct values of m. If f dash m is equal to 0, has two distinct roots where fm is equal to 2m cube plus m times 10 minus h minus 2. Now f dash m is equal to 6m square plus 10 minus h, right? 6m square plus 10 minus h. Put m dash as put m dash m is equal to 0. F dash m is equal to 0. Therefore, we will get m is equal to plus minus root over h minus 10 upon 6. M is equal to plus minus root over h minus 10 upon 6, right? So the values of m are real and distinct if h greater than 10, that is h belongs to 10 to infinity, right? So values of m are real and distinct if h greater than 10. Clear? So h will belongs to 10 to infinity. Therefore, option D should be the right answer. Got it? Option D is the right answer. Okay, let's move to the next question. Question number 14. Question number 14 says tangent and normal are drawn at point P 16 16 on the parabola y square is equal to 16x, which intersect the axis of the parabola at A and B respectively. If C is the center of circle through the points P, A and B, and angle CPB is equal to theta, then the value of tan theta is. We basically have to find the value of tan theta. Clear? So what we can do, the hint of this question is we are given parabola y square is equal to 16x, which is standard parabola. Now from point at point 16 and 16, which is lying on the parabola, we draw tangents and normal, right? And which are intersecting the axis of parabola at A and B respectively. Clear? So first we will try to draw the figure, and at point 16 and 16 16 we will try to draw the tangent and normal. Now if see the center of circle passing through PAB, so we'll draw a circle through PA and B, and center of circle C will be center of the circle will be C, and angle CPB is equal to theta. Clear? So after that, by using the properties of circle and triangle, we can easily find the value of tan theta, right? So in this way you can try to attempt the question. You have 10 seconds to solve or think about this question. After 10 seconds we will discuss the solution part, right? See, formula and key points we'll use in this question is equation of tangent to a parabola y square is equal to 4ax is basically y is equal to mx plus a by m, right? So let's see the figure. We are given a parabola y square is equal to 16x. At point 16, 16 we are drawing the normal and tangents, right? And these normals and tangents are intersecting the x-axis at a and b respectively. Clear? Now equation of tangent at p 16 16 is, see, slope of pc 4 by 3. Now slope of pb you can see this, hence tan theta will be slope of pc is known, slope of pb is known, so we can easily find the value of tan theta, which is mod of 4 by 3 plus 2 upon 1 minus 4 by 3 into 2, which is equal to 2, right? Therefore the value of tan theta is equal to 2. Option B is the right answer. Got it? Option B is the right answer. Okay, let's move to the next question. Question number 15. Question number 15 says P is a point on the parabola y square is equal to 14x and Q is the point on the line 2x plus y plus 4 is equal to 0 if the line x minus y plus 1 equal to 0 is the perpendicular bisector of PQ, then the coordinates of P is, we basically have to find the coordinates of P. So the hint of this question is we are given a standard parabola y square is equal to 4x, right? Now P is a point on the given parabola and Q is a point on the line which is 2x plus y plus 4 is equal to 0, right? Now if the line x minus y plus 1 is equal to 0 is perpendicular bisector of PQ, first we will try to find the point P and Q, clear? And after that we can easily find the perpendicular bisector, and the perpendicular bisector will be x minus y plus 1 equal to 0. So by comparing we can easily find the coordinates of P, right? So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds we will discuss the solution part, right? Okay, let's move to the solution part. The formula and key points we'll use in this question is any point on the parabola y square is equal to 4ax is 80 square and 280, right? 80 square and 280. Now reflection of point x1 y1 about the line ax plus by plus c equal to 0 is, we know that x minus x1 by a is equal to y minus y1 by b is equal to minus of 2 ax1 plus by1 plus c upon a square plus b square, right? Now let's move to the solution. Any point on the parabola p is parabola p y square is equal to 4x can be taken as t square and 2t. Now q is its image on the line x minus y plus 1 is equal to 0, clear? Therefore we can easily write x minus t square upon 1 is equal to y minus 2t upon minus 1 is equal to minus of t square minus 2t plus 1. Therefore the coordinate of q will be 2t minus 1 and t square plus 1, right? Since this q, the coordinates of q is lying on the line 2x plus y plus 4 is equal to 0. Therefore by putting the values of x and y, you will get 4t minus 2 plus t square plus 1 plus 4 equal to 0. Therefore t square plus 4t plus 3 is equal to 0. Got it? So t, we got t as minus 1 and minus 3. So the possible positions of p are 1 and minus 2 and 9 and minus 6. Clear? Possible positions of p are 1 and minus 2 and 9 and minus 6. Got it? So therefore option B, 1 minus 2 and 9 minus 6 is the right answer. Got it? Question number 16 says the locus of vertices of parabola locus of vertices of the family of parabola y is equal to a cube x square upon 3 plus a square x upon 2 minus 2a is. We basically have to find the locus of vertices of the given parabola, right? Given family of parabola. So what we can do, see the hint of this question is the equation of parabola is given. We will try to convert this equation into its standard form, right? And suppose we will assume that the vertices of the parabola be h and k, right? And after comparing, we can replace h with x and replace k with y, right? In this way you can try to approach this question. Clear? And after 10 seconds we will discuss the solution part, right? Got it? See, formula and key points we'll use in this question is vertices of a parabola x plus x1 whole square is equal to 4a into y plus y1 is basically minus x1 and minus y1, right? So we have the parabola y is equal to 1 by 3 aq x square plus a square by 2x minus 2a, right? So when we will convert this into a standard form, we can write x plus 3 by 4a whole square is equal to 3 by a cube into y plus 35 by 16a, right? So vertex p hk is equal to minus 3 by 4a and minus 35 by 16a, right? So a can be written as minus 3 by 4h and a can also be written as minus 16k by 35, right? Therefore locus of vertex p is basically when we will equate this minus 3 by 4h is equal to minus 16k by 35, you will get hk is equal to 105 by 64, and after replacing h with x and k with y, you will get xy is equal to 105 by 64, right? Therefore option a, xy is equal to 105 by 64 is the right answer. Got it? Now let's move to the next question. Question number 17. Question number 17 says the parabola y square is equal to lambda x and 25 times x minus 3 whole square plus y plus 2 whole square is equal to 3x minus 4y plus 2 equal to 0 are equal if lambda is equal to. If lambda is equal to. So we are given a parabola. See, if the hint of this question is if the two parabolas are equal, that means the length of their lattice rectum should be equal, right? So by the given parabola, we can find the length of lattice rectum. Clear? And for this parabola also we can try to convert this in a standard form, and we can try to equate the length of lattice rectum for the two parabola. So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds we will discuss the solution part, right? The formula and key points we will use in this question is two parabola are equal if the length of their lattice rectum are equal. Two parabola are equal if the length of their lattice rectum are equal, we know, right? And length of lattice rectum is 2 into distance between focus and directrix, right? Length of lattice rectum is 2 times the distance between focus and directrix. Got it? So let's move to the solution. Let us recall that the two parabolas are equal, we know, if the length of their lattice rectum are equal. Clear? So length of lattice rectum of y square is equal to lambda x is equal to lambda, is lambda, right? Clear? The equation of second parabola is 25 times x minus 3 whole square plus y plus 2 whole square is equal to 3x minus 4y plus minus 2 equal to 0. So now the distance of point 3 and minus 2, distance of point 3 and minus 2 from the 3x minus 4y minus 2 will be equal, right? Clear? Clearly it represents the parabola having focus 3 and minus 2. Clear? 3 and minus 2. And see, 25 can be written, 25 has been written as root over 3 square plus 4 square, right? So clearly it is basically representing the parabola having focus and 3 and minus 2, and equation of directrix as 3x minus 4 y minus 2 equal to 0, right? Length of lattice rectum is 2 times distance between focus and directrix. Therefore 2 times we can find the equation of directrix is 3x minus 4y minus 2 equal to 0. So we will we will equate the length of lattice rectum as 2 times 3 into 3 minus 4 into minus 2 upon root over 3 square plus minus 4 square is equal to 6. Got it? Thus the two parabolas are equal if lambda is equal to 6. Clear? Two parabolas are equal if lambda is equal to 6. That is 6 is length of lattice rectum and lambda is also length of lattice rectum. Got it? Okay. So option D, 6 is the right answer. Got it? Okay. Let's move to the next question. Question number 18. Question number 18 says a line is drawn from A minus 2 0 to intersect the curve y square is equal to 4x in P and Q in the first quadrant such that 1 by AP plus 1 by AQ less than 1 by 4. Then slope of the line is always. So see, the hint of this question is, first we will try to draw the standard equation of parabola, and from the line and from the point A, which is minus 2 0, we will draw 2 points on parabola, which is P and Q. Clear? And the 2 points can be taken by using the parametric equation of a straight line. Clear? Or 2 point can be chosen by using parametric equation, and after that it will convert into a quadratic equation in which have two roots. Clear? And after that you can easily find the value of 1 by AP plus 1 by AQ. Clear? By using the roots of the quadratic equation. So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds we will discuss the solution part, right? Part. See, formula and key points we'll use in this question is, if we have a quadratic equation ax square plus bx plus c equal to 0 have two roots, then sum of roots will be minus b by a, and product of roots will be c by a. And any point on the line drawn from x1 y1 which makes an angle theta with x-axis at a distance r is x1 plus minus r cos theta and y1 plus minus r sin theta. Clear? So let's move to the solution. Let point P minus 2 plus r cos theta and r sin theta and P lies on the parabola, right? So by putting these values on the parabola, we will get r square sin square theta minus 4 times minus 2 plus r cos theta equal to 0, right? Therefore it is now quadratic equation having sum of roots, quadratic equation having two roots, quadratic equation in terms of r. clear. And having two roots r1 and r2, therefore sum of roots will be minus b by a, which is 4 cos theta upon sine square theta, and product of root r1 r2 will be equal to c by a, which is 8 upon sine square theta, right? Since we basically have to find 1 by 1 by ap plus 1 by aq, which is basically, see, r1 plus r2 upon r1 r2 will be, okay, so cos theta will be equal to 1 by 2. Clear? Cos theta is equal to 1 by 2. If cos theta is equal to less than 1 by 2, then tan theta will be greater than root 3, because cos theta is decreasing and tan theta is increasing function in 0 to pi by 2, right? So tan theta, that is slope, should be greater than root 3. So m is greater than root 3. Got it? M should be greater than root 3. Okay. So in this way, we have discussed a lot of different types of questions based on parabola. Hope you understood the concepts, how to apply the concepts in the question, and hope you liked our lecture, right? Thank you so much.